Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another liquid problem that is the maximum performance of a team. So this is a hard type problem and we'll understand what this question is asking us to do and how we can think on finding a solution to this kind of questions. Okay. So before moving on, if you haven't subscribed to this channel, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. The question says so you are given two integers n and k. So that's the n over here and k over here. Fine. N and k, and the two integer arrays speed and efficiency. Fine. Both of length n. So n being the length of the speed and efficiency. Fine. So it says that there are n engineers. Okay. Numbered from 1 to n. So that's the n engineers are there. And it further mentions that the speed of at any position I, speed and efficiency of position I represent the ith engineer respectively. So that means that for each of the engineers, there is given a speed, respective speed, and respective efficiency for them. Okay. Now, what the task we need to do? It says choose at most k different engineers. So we need to choose k number of engineers from this n number of engineers given to us. Okay, and out of the n and engineers on the to form a team with maximum performance. So we need to find a like form a team of k out of this n people, like n engineers who have the maximum performance. So what is the performance? It will be given to us, like it will be mentioned. Okay, let's read further. So the performance of a team is sum of their engineer speed. So sum of the speed multiplied by the minimum efficiency, or like the minimum efficiency among the engineers. Okay, so sum of the speed multiplied by minimum efficiency among the engineers. So that's the performance. So we need to find this. Okay, now further it says return the maximum performance of the team. So we need to return the maximum performance of this team, and since the answer can get lost, so we need to do a module of 10 to the 9 plus 7. Okay, so that's obvious. Now let's understand an example. Okay, the example says the speed given to us is like 2, 10, 3, 1, 5, 8, and the efficiency given to us is 5, 4, 3, 9, 7, 2. So that's the efficiency given to us, and it's like the 6 people are there and we need to select 2 people around. Okay, so output is 60. So let's understand how is that happening. So firstly, we need to select one. See, we need to do a sum of the speeds. So speeds are something that's going to be added. Okay, so, and we need to do a minimum of efficiency. The efficiency should be a minimum, like with their speed, we should multiply the minimum of their efficiency. Okay, whoever is selected, among them, the minimum efficiency will be multiplied. Okay, now look here. If we need to maximize the performance, so it's like sum of our particular speed, right? So sum of a speed that's multiplied by we should know that mean of our efficiency, right? So mean of our efficiency, like all of the efficiencies are there, that should be like taken care of. Okay. Now, what will happen? See, the idea is like pretty simple. Like, okay, try every efficiency value from highest to the lowest, from like 9 till t. Like check for every efficiency. Okay, and at the same time maintain as large as possible speed group. Okay, so like keep take every efficiency from highest to the lowest. Okay, and check for which efficiency value the speed is also not too bad. Okay, like not too bad. What I mean is, if you are getting a speed of 10 with efficiency of 4, would you take a speed of 1 with efficiency 9? I mean, anyways, the other person you are choosing is probably less than that, right? Because 9 being the highest efficiency, whoever you choose, other person, say you choose 7, you choose 5, 4, 3, 2, anyone, the minimum of them will be selected, right? The minimum of them will be selected. That means anyways your efficiency is gonna decrease, right? So in that case, if you're choosing a speed of 1, that's useless. So you should try choosing a person that's having a higher speed and a decent efficiency. I mean, If you're choosing a person with speed of 10 and with the efficiency 4, that's good, because if you're who's the other person you're going to choose? See, so we will not go best on the speed, because we know that our efficiency is, well, like speed is something that's simply going addition, okay, but efficiency is something that's giving us a, like, minimum is being taken off, okay. So whoever efficiency they're taking is not the person who is having that efficiency continuously. That's their speed will be taken off, like efficiency will be taken the minimum, right? So first if we take first if we take our this 9 being the highest efficiency we find here, okay. So what will happen if we take 9 as a one of a person, fine, and if we take like any other person, 6 7. So if we take 9 and then we at least need to take 7, because we need to choose two people, right? So we at least need to take 7 or anyone less than that. So if we choose 9, then we are sure that if, like, the effective efficiency that is going to hamper our performance won't be 9. That will be the next person we are choosing, because the next person we're choosing is the minimum you can choose is 7, right? If you choose 7, then the effect, like the in the effective performance, our uh, like the value getting multiplied is 7. So 9 doesn't care for us, right? So if we're seeing that for taking 9, we are getting a like a minimum speed of 1. What's the point of taking 9, right? We should check if there's any other value below 7, there's a 5. Okay, so if we take 5, we are saying that, okay, if we take 5, we are getting a speed that is a bit more than 9. I mean, we anyways see, we are losing two values in multiplication, but we are gaining something in speed that is going to add, because 7 is something that's giving us a value like 5, right? So 5 plus 2 is going on. Now we will check again further. After 5, whom can we take? Can we take 4? That's the second, the next smallest. If we take 4, what's the value of speed we have? We are getting a speed of something like 10, right? Uh, that's a huge jump in our speed. So why are we taking this 7 and 4? The idea is, out of this two, anyways, our minimum will be taken, right? Our minimum will be chosen up. So the minimum is something like 4 is getting chosen from this 7 and 4. But in terms of the speed, see, in terms of the speed, we are getting a speed of 10 and 5. So speed of 10 and 5 is something giving us a 15, right? But you may ask why we are not taking 8 then. Taking 8 will give us a higher speed. I mean 10 and 8. But if we take 10 and 8, so in that case, our minimum efficiency will be 2. So 10 and 8 gives us 18, but efficiency reduces to 2. That gives us a lower value. So we cannot directly predict out of seeing the numbers. So we need to check for all the values we have. For all the efficiencies, we will keep on checking. Okay, now, what will be our idea is, okay, the idea will be we'll have a like case-based array or a priority queue based on that, and in that we will store them based on the, like, if any engineer having X is, like, whenever our case-based priority queue is getting over, how will you reduce the value? It will be like, if any engineer with the lowest speed is found in our case space, then we will just like lay off that person, okay, with the lowest speed. So that's the, like, we need to increment the speed, and at the same time don't go too far below our efficiency, okay. So what will be our steps one by one? The first thing, we'll sort this efficiency in descending order. So remember, whenever we are sorting this efficiency, we need to remember that we should sort this speed also at the same time, okay, so that the one-to-one like the one-to-one pairs of the speed and efficiency of each of the engineers don't get changed. So first thing, we should sort this efficiency on descending order. So we are reducing the efficiency, okay, and checking who can be a better fit for us, okay. And further, then we will maintain an minimum of priority queue. A priority queue is minimum to track the minimum speed of the group. Okay. Now, in that, if any speed is getting, as I said, whenever we our priority queue exceeds this size, we remove the person with the lowest speed and add someone new in its place. Okay, so that will be our idea. And further, we'll simply calculate our value, calculate our performance value at each step. And on each step, once we calculate a performance value, we'll find who becomes our biggest performance, like the maximum performance, where we find the maximum performance. So wherever we find the maximum performance, we'll simply return the value. Look, we are not bothered to return who are those two engineers, right? We are not bothered to return who are those two engineers. We are bothered to return what's their maximum performance can we get. So once we find the maximum performance, we simply return the value. We don't need to store the individual engineers at any place. Okay, so that's the idea. I hope it's understandable. In like next few minutes, I'll just write the code and tell you this exactly same thing in a way how the code can be written with what we are thinking on this. Okay, let's quickly go ahead and write this code. Okay. So here you can see that this works. So the first time we got a wrong answer, the wrong answer. So if I've seen that part clearly, you can see that the answer was nearly same. The last digit was like 3 expected and we got 4. Okay. So that was the error. So whenever you see this kind of error, you look carefully for this kind of like whenever this kind of modulation operation works. So that's the reason for those kind of things. Now, in this, what we changed actually, we actually took another variable that is the integer type mod of variable that is like 10 to the power 9 plus 7. So that's the value we are asked to do the modulo of. Fine. And finally, we just made it like result mod. We made it a long type variable and like converted long because race is already in long, and then did the modulation and then convert to int. So this kind of conversion, in this kind of conversion on large values, you will actually, you may see this error. So it's better to go ahead with this kind of way, not directly writing 1e9 plus 7 in this. Okay, so take another variable and do that. So that gives a better way. Now, what exactly we did with this whole code, the rest of the code. The code was like, we first task was to sort the engineers by efficiency, descending efficiency. So you see, like the first thing we did, we formed our engineers. Okay. Now you can actually do three things over here. If you are good with or like classes and objects, then you can actually form an engineer class with two different ideas with it. Two different ideas. Like one, you will take the speed as a variable and efficiency as a variable, and take a constructed of it, like take the speed and efficiency as a variable and take a constructed. Okay, so you can do that kind of way. Or yes, in over here, I went ahead with the 2D array of engineers. But if you're doing with that way, it's probably would reduce your total time, not the complexity. It will reduce your time. You will see a reduction in time. That's true. Now, so we did a 2D array where each of the engineers is being denoted as a 2D segment. Fine. Now, further we find we are just sorting this engineers on the basis of say b minus b0 minus a. What is zero? Efficiency. So efficiency, whenever you see b minus a, that's a decreasing order. Okay, whenever you see a minus b, I mean a comma b, that's a minus b, that's increasing order. Okay, like ascending order. So whenever you see this b minus a, that means it's going on in a descending order. Fine. So this is a descending order. So the near one you'll find particle that's ascending order. So I'm just telling you the difference. So we are sorting this engineers array based on the descending order of our efficiency. You said the B0 and A0. So what is the B1 and A1? B1 and A1 gives us the speed, right? Then what's our next task? Next task we took a priority queue. But why? Priority queue is like to store the slowest engineers. Okay, so slow all the slowest engineers based on the speed. Okay, and we need to take those speed. We need to take a sum of the speed, right? So that's what we want, right? That's what question says, is sum of the engineer speed. So we're taking the speeds in our priority queue. Now, further moving into our main operation, we took another two things. One, a long time result. that's we initialized as a min value, and another a total being the total speed we have till now. Okay. Now remember, our engineers array is sorted in descending order of efficiency. That is the largest efficiency, like the greatest efficiency. That is, it's like 9, then 7. So these are at the top. Okay. So that's how our engineers array is sorted over here. Now we took, like for each of our engineer in our engineers array, what we took, if our parity queue is full, we simply popped our last element, like the top element. Priority queue is going on in a slowest order, like in ascending order. So the person with slow speed will be at the top. In case our priority queue is full, we simply do something like top speed, like the total speed minus our PQ dot poll. Like whoever has the slowest point, we just poll them. Our priority queue is full, right? We just polled them, taken them out, and then added our engineers one. Engineer one is what the speed. The speed is adding. We are adding the speed to our priority queue. Now, once I add the speed to a priority queue, the total speed becomes engineer. Like total speed is because whatever speed it was, we added the engineer one to it. And what's the result? Our total speed multiplied by the min of our minimum of efficiency, right? So that's the minimum of efficiency we should go ahead with. So why I took directly engineer zero? Because whoever is the current engineer at this position, our engineers is sorted in descending order of efficiency. So whoever is the current position is the lower, who is having a lower efficiency than the other engineers who we encountered before, right? So we can directly go ahead with the current engineer's efficiency, and once you know the current engineer's efficiency, we are sure that he has the lowest. Whoever the other person is, he has the lowest. So min is directly this person. Okay. Now, further, we just multiply total speed in this or the result, previously result. So whoever has a maximum value, we just keep storing in our result. Okay. So after this whole process, whatever maximum value we got, we simply do a maximum value modulus of our 10 to the power 9 plus 7. So that's the modular operation we're doing. And then returning this as an integer because our return type was integer. So that's the whole thing with it. Okay. This is the whole idea. Now, this is kind of the best idea you have. Now, how you can reduce the speed? I mean, the complexity is pretty that much. Because the complexity you cannot change much because you need a priority queue anyways. So priority queue is n log n is going on anyways. Okay. So whenever you are adding, n log n is going on, right? So how you can improve this? How you can improve this? You have you can do some kind of different ideas. The different ideas exactly mean you can try with like a different like storing capacity of this engineers. Like you can directly store as objects. So in that case, it will be much faster because that is coming from the heap memory, right? So you can try out with that, or you can make this sorting on your own. Maybe if you know some better sorting algorithm, maybe you try merge sort or something. But those like sorting won't help you much. But changing this as an object might help you a huge, like highly. Okay, so that's the more or less the whole idea of this question. Now, I hope you can understand how you can actually solve this question and what are the things you should like remember in mind, or how you can actually think of finding the solution. So first thing is sort the engineers in efficiency by descending, and then store the slowest engineer in a priority, like whoever having the slowest one. Okay, like keep on storing their like take a priority queue in ascending order, like the min heap format, and whoever is the going the slowest, if a priority queue size is full, will remove the slowest and increase, like add a person who is having a better speed. Okay, but efficiency needs to be like minimum. Okay, so that's what we do. So efficiency is descending order. So that's what we more or less try to do. If I just simply talk about the complexity is, you all know it has a complexity of n log n, like n log n for our sorting, because we're sorting for n elements. And then for this priority queue, we have n log k. Okay. And for the space complexity, you have nothing more, simply n spaces are required, the order of n. So because that's the enough space we are taking, and obviously k is lesser than n, right? So that's anyways that will be true. See, the k is less than equals n. So for that, it doesn't matter. This order of n is also only going on. So that's the whole idea of this question, guys. That's how you can actually solve this question. I hope I can make you understand how you can solve this question. So make sure to like this video and subscribe to this channel for regular videos like this. And also comment down your thoughts if you have any doubts or something like that. I'll be happy to help you out in the comments as well. So thank you all for watching this video. Hope to see you soon in my next video. Thank you.